Good evening, everyone. My name is Joel Samuels, and I'm the Interim Dean of the College of Arts and Sciences, and it's my pleasure to welcome all of you to tonight's keynote presentation as part of this year's theme semester in the College of Arts and Sciences. The College of Arts and Sciences launched theme semester 2 years ago, initiated by former Associate Dean Cynthia Davis, to bring together the wide range of academic perspectives in our college around a single subject area. One of the things that makes the College of Arts and Sciences both distinctive and at times challenging is the breadth of areas where our students study, where our faculty research. Our college encompasses everything from theater and dance and the School of Visual Art and Design through to biology, biochemistry and chemistry, physics and astronomy, and everything in between. And so finding ways to unify and unite the work we do is in some ways a challenge, but actually for us, a really fun opportunity to think about the things that make us a special and unique place for the student experience and for research. The whole idea of theme semester is to enhance the student experience and to showcase the ingenuity of our faculty by connecting this year's theme, climates, to more than 30 courses and 15 activities beyond the classroom. The theme invokes the urgent conversations taking place today about our changing global climate, as well as our dynamic political and social climates. So the term is intended to have the multiple meanings of the word climates. Participants across campus and in our community have been taking part in film screenings, book talks, exhibitions, and scholarly roundtables. They are exploring all the climates we inhabit by studying marine science, literature, Italian food systems, criminal justice, mathematics, and more. One of the things that makes this initiative so important is that it models the way we actually learn and solve problems by sifting through multiple and sometimes opposing views and testing out different critical methods. Tonight's keynote address from Richard Alley will provide a cornerstone for the conversations we're having in the college throughout the fall. And in a minute, I'll turn to my colleague, Lori Zielkowski, to talk more about tonight's presentation. Before doing so, though, I'm also pleased to announce tonight that next year's theme is play. Given the stress that most of us have experienced from changes in our climates over the past 2 years in all of their senses, this next theme will help us explore the important role of play in education, mental health, and society. More information, including a call for grant proposals for courses and co-curricular activities, will be shared in the coming weeks. But I'm excited to be able to think forward to that theme as we move into next year and to reflect on our theme for last year, justice, as we think about the ways in which our unique college brings together so many diverse disciplines and can engage them in singular conversations. Like so many of you, I'm excited to see Richard Alley do just that in a short moment. But for now, I'd like to turn over to Professor Lori Zielkowski from the School of Earth, Ocean, and Environment. Lori?
Thank you, Dean Samuels. I really want to be able to speak to the concept of having these themesters and that it gives us creativity in the classroom. And so I am one of the recipients of a specialty grant that was as part of the themester. So I'm teaching a class this semester called The Science of Climate Fiction, where we're not only talking about the typical class on science of climate change, etc., but we're using novels to be able to talk about that. And that's broadened not only my students' perspective, but I would also say my own perspective of how to think about climate change. So I think there's many benefits for both the students and the faculty to have opportunities like these themesters. And so to that end, I'm going to pass it over now to Professor David Barbeau from the School of Earth, Ocean, and Environment to introduce Richard Alley for tonight. Thank you.
Thanks much, Lori and Dean Samuels. The late mathematician Richard Wesley Hamming of the Bell Labs is known to ask one of his colleagues, if what you're doing is not important, and if you don't think it's going to lead to something important, why are you working on it? I'd argue that a close second to doing important work is being able to speak about it effectively. We're thus incredibly fortunate to hear from one of Earth's most important and eloquent climate scientists for his keynote talk for the College of Arts and Sciences Climate's theme semester. Dr. Richard Alley's achievements in both climate science and climate communication are amongst the very best in those endeavors. Richard Alley is a geologist and a glaciologist. Amongst many other things, he's a member of the National Academy of Sciences and a fellow of the American Academy of Arts and Sciences. He's the recipient of the Lewis Agassiz and Wollaston Medals and the Seligman Crystal. Amongst his more than 200 publications, he has published several in Nature and Science. And as the lead author of the 4th assessment report of the United Nations Intergovernmental Panel on Climate Change, Richard is a recipient of the 2007 Nobel Peace Prize. He's presently the Evan Pugh Professor of Geosciences at Penn State University. Please join me in welcoming Dr. Richard Alley to the Climate's Theme semester. Members of the audience, please feel free to ask questions as they arise in the Q&A function. Dr. Zielkowski and I will curate those questions and ask them of Dr. Alley at the end of the talk. Without further ado, Dr. Richard Alley.
Thank you. Greetings. It is truly a great privilege for me to be here. I'm going to try to share my screen here and we'll see if we can get it to work. And I'm going to try to make my ability to scribble on it in a funny pen color here. So we'll do that. It is truly an honor and a privilege. What you're doing with climates, I wish I could come see play. What you're doing with climates needs the full breadth and depth and strength of you. And you are uniquely positioned to do that. So it's a really wonderful thing. I'd like to thank your distinguished faculty for having me, the good people who introduced me. Associate Dean Kiana works on comic books, and that is play that is really serious and you can learn a lot from. So so it is a pleasure to be here. So thank you to these good people, and thank you especially to you students, you community members who are there, because we do need you. All right. The penguin pictures are just for fun. They're from some of my trips to interesting places, and they lighten up something that otherwise can get a little bit heavy sometimes. So as Professor Barbeau said, I'm a geologist. I've got a little bit of a background in some engineering. I spent one summer with an oil company. We study ice to learn what will happen to sea level, what is the history of climate, and how did it make Yosemite pretty. Personally, my dear wife, Cindy, was a geologist who became a quilter and made my background here. We have 2 daughters. One of them is a science teacher. One of them is a science professor. We have 1 cat. Other than that, I've been at this for a long time. I started glaciology as a freshman at Ohio State in 1977. So I'm grown old. We have a great research group here. If you ever get interested in the ice, we have a great research group here at Penn State. Here's a few of the current grad students. Lizzie just graduated. And I've had this wonderful good fortune that the science that I do has wonderful people in it. I get to go to the prettiest places on earth with the best people and learn what nobody knows and bring it home. And sometimes that gets interesting. And so I did get to work with the UN. I spent a long weekend in Greenland with 10% of the Senate. And so I have had this opportunity to learn a little bit about how the science fits into some bigger picture. And I'm going to try to share a little of that with you here. So we're going to do the big picture on climate and energy. This is still narrow compared to your whole climate's effort, but maybe I can illuminate a part of that a little more. And so, the big picture on climate and energy is that if you read the news, it's often not really good news. But before you go take the long walk on the short pier like these penguins down here, think of what we really know. So this is us in 2007 with in Paris. They locked us in a room and we spent a week arguing over words, and all of Paris is outside and they're bringing us dinner that's these little plastic wrapped sandwiches. But in the end, we got this, and we were the 4th assessment. The 6th has just come out. If you printed all of our reports and stacked them up, they would disappear through the ceiling of our room here. If you turn them into a tweet or two, what does our scholarship really say? Think of a future where we ignore our knowledge And now think of a future where we use our knowledge efficiently. We actually do know if we use our knowledge efficiently, we get a larger economy in which more people can have jobs. We improve our health, we improve our national security. And by the way, the environment is cleaner and we're more ethical. Right now, using our knowledge efficiently will help the environment and the economy. That's what we know. And you students who are here are the first generation in all of human history that knows that you could build an energy system that is both sustainable and economic. It will power everyone essentially forever. That we know. It's not going to be easy, but to do that, we have to remember, and we really do have to remember, that we can solve problems. And then we have to go out and solve them, because it's easy to forget that we can solve problems. It is easy to start thinking they're a little too big and we can't get along long enough to do it. Okay, so I want you to think about your cell phone for a minute. You may be watching me on your cell phone, or you have a computer and your cell phone's in your pocket or somewhere. What's a cell phone? And I have a do-it-yourself cell phone kit on the left here. It's a little bit of quartz crystals, some sand to give you the glass, to give you the silicon for the chip. It's some sort of organic matter, such as oil, to give you the plastics. It is the right rocks, not these, but the ones with the palladium and the rare earth elements. And that's all it is a little bit of sand, a little bit of oil, and a little bit of rocks, and science and engineering and design and marketing. If we did not understand relativity, if we didn't have Einstein, the GPS in the phone would start to get lost in 2 minutes, and it would dump you into the harbor down at Charleston and tomorrow or something like that, because the satellite is going faster and is farther up in Earth's gravity well than you are. And so we use relativity, we use quantum mechanics. You have relativity and quantum mechanics in your pocket. We can solve problems. Okay? I'm going to focus on a little piece of this. I'm going to focus on energy and climate. Energy. I hope you got your dinner already. A human diet in these archaic units is about 2,000 calories per day. That's what we eat. If you were to take that 2,000 calories and burn it over 24 hours, the energy that comes off is just enough to run one old light bulb. If I had to ride my bicycle to make the electricity that lights my room, I would be out of breath. A Tour de France rider can do maybe 500 watts, but they eat 10,000 calories a day. I don't have to light the room. I don't have to heat the room. I did not have to hoe corn all summer, so I wouldn't starve to death this winter. It was done by a tractor. What is done for us in the United States is about 100 times what we can do for ourselves. You have the labor of 100 times what you can do. Heating and cooling and lighting and plowing and trucking and all of those other things. And right now, it's about 83% fossil fuels. And when we talk about why climates are difficult, how much good we get from fossil fuels and how many we use, this is why it's difficult. Now, we have a long, you can write history from so many perspectives, but you could write a history of humanity as simply this: we are hunter-gatherers of energy. We want something else to do our work for us. And what we tend to do is find something to burn to get the energy out of it, burn it a lot faster than nature makes more, suffer the consequences of breathing pollution and deforestation and other problems, run out, have wars and government interventions and other problems, and then find something else to burn and do it all over again. And I want to walk you through a little of this history of us trying to supply our energy thirst. before we get to the current issues. Okay. So I'm speaking to you from just down the road from Penn State University. Penn State University is in a town called State College. State College is a suburb of Penn State. If you look at when they were founded, Penn State is older than State College. State College is the bedroom for the university. The university was founded by the iron masters, the people who were making iron here in Pennsylvania. And this is the old iron furnace. The glass slag from the furnace is under the road there. When the furnace was working, it looked like this. This is from down towards Philadelphia, but this is Hopewell furnace. But when the furnace was working, they were taking red dirt with limestone flux, and they were making the iron that was used to build railroads and other things. So there's all kinds of stuff is being done with this iron. And the fuel was charcoal. And so what did they do? They cut trees, lots and lots and lots of trees. You pile them up, you bury them in, these old codgers were demonstrating how they did it when they were young. So this is just a stage thing for a reenactment for historians. But what do? You bury the trees in dirt, you burn it with restricted oxygen, you drive off the water and some of the volatiles, you make something that will burn hotter, and then it's just hot enough to smelt the iron out of it. And it did this. A furnace, one furnace. And the people who took care of it took about a square mile of trees per year. So if you can think of going out to a forest, walk for 20 minutes, take a left, walk for 20 minutes and square it back, that's enough trees to keep one furnace and its people going for 1 year. And then it's 50 years until you can do it again. It's an immense undertaking, just an immense amount of energy going on. If you go to a map of Pennsylvania today and you ask, where do we in Pennsylvania remember the furnaces? Everything on the left of this plot is a furnace. The ones on the right, they made pig iron, and then they shipped it to forges. Everything on the right is a forge. Valley Forge is right down there. Every line on here, plus a whole bunch more lines that are forgotten, is a square mile of trees a year. And what did it do? It did this. Pennsylvania, my state, my commonwealth, means Penn's woods. When European settlers arrived, they said all up and down the East Coast, including you, a squirrel could go up a tree on the Atlantic coast and stay in trees to the Mississippi. The first forester of the Commonwealth of Pennsylvania wrote about the Pennsylvania desert. Now, it wasn't a desert, but we essentially had no trees left in the entire Commonwealth of Pennsylvania. Our team is called the Nittany Lions. We don't have any Nittany Lions left. There weren't any deer to eat. There weren't any trees to do it behind. Pretty much anything bigger than a rabbit or a squirrel, we got rid of after we got rid of all the trees because there was just nothing for them to do. We just flattened the place because we were using it in large part for burning. And it's not just us. If you haven't seen the South Carolina Encyclopedia, it's a wonderful thing, and I recommend it to you. And so here's an iron furnace of yours, sort of up into the north and west of you there. And you'll notice the quote from the South Carolina Encyclopedia down at the bottom. By the 1850s, South Carolina iron was suffering from a depletion of timber resources. You did it too, okay? Everybody did. The Pilgrim, if you know, this is Cape Cod, my arm here. Right here is First Encounter Beach. This is where the Pilgrims land and meet the native people in 1620. Okay, this is in the town of Eastham. When the Pilgrims land on Cape Cod, they say it was so goodly a land and wooded to the brinky of the sea. Still in the 1600s, the town of Eastham outlaws your own ability to cut your own tree on your own property because deforestation had become so extreme, they did not know what to do. When Thoreau walks the Cape in the 1800s, he says many of the people get all of their fuel from the beach. Unless there's a shipwreck or a big tree washes ashore and you get it before someone else, you can't cook dinner because you don't have any fuel. Now, Eastham in the 1600s, what they're doing, they're boiling seawater to get salt to pack cod to ship to England. How did they fix it? Eventually, they went to renewables. They used windmills to pump water into solar drying troughs. Manhattan is passing laws about how much is a cord of wood and who gets to tell if somebody is cheating somebody else. When things get scarce, governments get in your face because it's demanded of them. And if you really are a libertarian who doesn't want governments in your face, you better not run up to the scarcity because it happens. Okay? Now, if you've ever tried to read by firelight from trees or even from candles, it's really hard. So what do you do of a dark night, whether you're in Columbia or in State College? Poor people used to use a lamp fuel called camphene. It was a mixture of alcohol and turpentine. It was pretty cheap. It burned pretty bright and clean, but it was sort of white gas explosive. And there's horrible stories. The Methodist minister and his wife go out to visit the parishioners, and the three daughters try to refill the lamp, and it blows up and it burns the house down and kills all of them. And so rich people used to burn whales. So you send a lot of money over to the coast, and they send people out to kill whales and to cook the whales and to get the oil out of them. And then they send it home and it burns clean and it doesn't stink and it doesn't explode. And this is the history of whale oiling of the US fleet, right? 1800s on your left, 1880 is over on your right. And this is them getting good at whale oil production. There's peak whale oil for the US fleet. There were whales that these guys couldn't catch. So there's actually another big bulge over here with harpoon cannons and diesel and so on. And that's Norwegians and Japanese and Russians and others. But basically, we killed all the whales in the ocean that we could get a hold of. As a going resource, we basically killed all the whales. When we got good at it, the price started out pretty high, and then it got down here to, that's sort of in modern money, it's sort of $15 a gallon or $12 a gallon, something like that. And then when it hit peak whale oil, it goes up to $25 a gallon in modern money. And at that point, somebody walked up the road here from where I live. Oil was leaking out of the ground. Oil had been leaking out of the ground for thousands and thousands of years. The native people used it to seal their canoes and things like that, and said, hey, if oil leaks out of the ground, maybe there's oil in the ground. Drilled the first modern oil well. Okay. So there's what you have. The price goes through the roof. Governments are getting in people's faces, and then we drill the first modern oil well. Couple points. At the peak here, there's 10,000 sailors on ships whaling. This is immense effort to kill all the whales they could kill. If you took all of that oil from 100 years of whaling and you put it in oil tankers, it would supply modern US oil use for 11 hours. 100 years of whaling, 10,000 sailors at the peak, 11 hours. The idea that when we run out of oil, we go back to trees and whales is absurd. There is no chance that we can go back. But we have trees and whales because we switched to burning fossil fuels. We burn fossil trees, we burn fossil algae, and we let the trees and the whales grow back. And this is not a new idea. So this is an editorial cartoon. It is from the magazine Vanity Fair in the year 1861. So this is just before the US Civil War. And so you can read here, the oil wells of our native land, may they never secede. The whales want oil, right? Oil's well that ends well. We wail no more for our blubber. We have whales because we quit burning them. We have trees because we quit burning most of them. This is a piece of sheet music from the year 1864. This is the American Petroleum Polka. We're going to go dance to the beauty of oil. This is an oil field in Pennsylvania. The lady in her pink frock here. Oil has always been black. It is still black, but they couldn't have black oil raining down on her pink frock, so they made the oil white. But you're going to dance, you know, this oil well drew pure oil 100 feet high, okay? Oil is worth dancing for. The trees, the whales, most of them grew back in 100 years. The fossil fuels will grow back in 100 million years. It is absolutely unequivocally impossible to choose between a renewable energy future and a fossil fueled future. We either burn and then we learn, or we learn while we burn. There's no third option, because we are using fossil fuels grossly faster than more are made. And if we burn before we learn, we are going to change the climate in ways that we really don't like. The basis for me saying that is just physics. It is physics that was known in the 1800s. It is physics that was really refined by the Air Force after World War II. Now, the Air Force was not doing global warming at that point. They were doing heat-seeking missiles. And the heat-seeking missile has a sensor. It's looking for the infrared radiation from the hot exhaust of the enemy bomber. And if you put the wrong sensor on, CO2 absorbs it and you can't see the target. And if you looked outside today, there was more infrared going up from the sun-warmed Earth than was coming down from enemy bombers. And that's all you need to know about global warming. This is, before satellites were launched, they predicted what the satellites would see. They were right. This is the Earth sending energy back to space from the warmth of the sun. And this is not getting out because CO2 is in the way. And if there were more CO2, more would be blocked. And that's it, because we are raising CO2. Now, if you put that into models, you can start the models in the past. Back here around 2000, the models predicted what the future would do. The colors are what happened and different estimates. The black is what was predicted. These models are working. They are accurate. They are good. The temperature is rising. We're responsible. The models have been accurate, and there is no serious question about that. If you want to argue about that later, we can come back to it. I've got the goods. But us changing climate, we are. This is. It doesn't tell you what to do, but we are. This is. Okay. And as I say, Arrhenius made the first serious calculation in 1896 of how much fossil fuel burning could warm the Earth. He got the physics sort of okay right. He got the economics really stinky. He did not think that we would burn that much fossil fuel. And what he missed is how good the oil companies have been at giving us what we asked for. And we said, we want lots of this, and we want to be able to burn it to get the good from using the energy. And they provided it. And they provide immense amounts. All of those coal trains, that's stuff. And when you burn it, it's still stuff. All of those oil tankers and those oil pipelines, it's stuff. When you burn it, it's still stuff. Here's a scaling. You know what trash looks like. You have taken the trash out. You've seen the garbage trucks. You've seen the trash dumps. In the United States, per person per year, we throw away at the curb for the trash collector 1/2 ton of trash. Our share of the CO2 from the US economy is more than 16 tons. Half a ton of trash, 16 tons of CO2. That's the surprise. And it is changing the climate. Now, I will come back to the good news. What happens if we use this knowledge efficiently? But first, let me do a little scary stuff. What if we don't? And the big things, first, what's going to happen in your future is bigger than what we've done so far. Little changes, there are winners and losers. That's what we've done so far. As the changes get big, it's almost all losers. The cost goes up faster than the temperature. It's super linear. And the uncertainties are heavily on the bad side. It could be a little better, a little worse, a lot worse, but not a lot better. What do we worry about? You could live to see a time that there are places on Earth that if you went out naked in the shade, drinking water in a breeze, you would die of heat. That doesn't exist anywhere on Earth right now, but it could happen in your lifetime if we're not careful. Long before that, unprotected people are not working there. They're not happy living there. Sea level rise. Warmer air can carry more water. When conditions are right, it rains faster and you get more floods. Every clothes dryer, every hair dryer has a heating element because it dries faster. And so in a warmer world, after that flood, it dries out faster and you get more floods and more droughts. And you can see the others. There's a lot of issues that we worry about. Let me illustrate a couple of these. This is Syria. Syria had a civil war. This is 500,000 people dead, right? This is scholarship. Did a drought cause a civil war? No. There was a drought in neighboring countries that did not have civil war, but drought was a stress multiplier, and the least happy country there, the drought was a contributor to it breaking. Did we cause the drought? No. We made it 2 to 3 times more likely to happen. We loaded the dice to come up drought. It came up drought. The least happy country broke. Okay. And I will come back in a minute. This sort of analysis is done by our military leaders. So this is, I'm not making things up. So this is, if we do not change our energy system, what will happen to drought by the time you students are old? And on this plot, green is less drought, but be very clear, you're still not growing anything out here. Every other color on here is more drought. And up here where Syria is having unhappiness because of drought, lots more drought. You're not too bad down here, but you know what's going on out here, more drought. What's going on to a whole lot of people who might not be happy getting really hot, more drought. The sea is rising. Here are the data. The rise is happening. It is accelerating. It is because of warming. We are responsible. So far, it's not very fast, but it already is starting to matter. So this is a picture that I swiped from the web. The site is down here. I'm using it in fair use. And this is not a canal. It's a street. This is not a storm. It's a king tide. It's just a high tide. You can see the driveway coming down here behind the pickup truck. The people do not want big people driving giant wheeled vehicles through the water and splashing salt water up on the grass where it kills the flowers. And so what do? They call this adaptation. You put up a no wake zone sign from out in the ocean in the middle of your street when the tide goes up. I could show you pictures from earlier this week in Charleston too. Right. This is a parking garage in Miami, same story. You don't want salt water on your concrete because it'll get in there and break things. The octopus did not get thrown here by hockey fans. The octopus did not get blown there by a giant storm. This is just a high tide. The octopus swam in. Okay. They call this nuisance flooding. But at some point, it gets expensive, because at some point now, you may have billions of dollars to keep it from getting in your water system and causing other problems, and it may cause buildings to break and other sorts of things. So as the sea goes up, the cost goes up faster. And what is a nuisance suddenly becomes, we have to build a wall, we have to get a new water system, we have to do something. This is New Orleans from a hurricane that did not get over the wall. I would not have wanted to be this peace officer, but this hurricane did not get over the wall. We're already committed to enough sea level rise that you will have to raise this wall for this hurricane. But our research is addressing the possibility that sea level rise would just disappear out of this picture. Right now, the IPCC projections are that out to 2100, under strong warming, that more than 99% of the Earth's ice will not melt. But they're starting to entertain the possibility that maybe a lot more of it would melt. And so the uncertainties, maybe a little less melt, maybe a little more melt, a little less sea level rise, a little more, or an ice sheet collapses and it disappears out of the picture. Yes, we're uncertain. No, that is not good news. So if we can deal with this, more money, more jobs, better environment. Okay, I'll show you one slide on each of these 6 bullets. Okay, just one, but let's see what we can do. I served on a committee with Bill Nordhaus. He won the Nobel Prize in Economics in 2018 for building tools that allow decision makers to know the economic impacts of their decisions. Those tools show across the board now that a wise response on energy and climate helps the economy. You'll meet the person who says, oh yeah, climate change is happening, but we can't afford to deal with it. The Nobel Prize in Economics says you can't afford to ignore it. I did work for an oil company. Our students get jobs for oil companies. They have great jobs. But what the data tend to say is that the alternatives make more jobs. And this might be because the cheapest oil producers can produce oil a lot cheaper than what they get paid. $5 a barrel for workers, and the rest just goes for controlling the resource. Controlling the sun, you've got to make it useful. You have to pay workers. So it's fairly clear that moving away from fossil fuels makes more jobs. These are health groups. And they have pointed out that we have all kinds of problems with air pollution. Most of air pollution comes from burning, which either is fossil fuels or is made worse by fossil fuels. And so they said the most important action we can take to protect health is to accelerate the transition to clean energy. There was a recent study that said that globally, 1 in 5 deaths happened prematurely because of breathing pollution from burning of fossil fuels. 20% of the world's deaths. This is Rear Admiral Tetley, David Tetley. He's a Penn State grad. He's a friend of mine, but he was a Rear Admiral, and he is trained in weather and in climate. He was the oceanographer and the navigator of the Navy. He served on the board that looked at national security issues. And they said, if we want a secure nation, we need actionable agreements on ways to stabilize climate change. Making people really unhappy where they are and driving them across borders does not help national security. Triggering wars does not help national security. They see climate change as not as a cause, but as a threat multiplier. And then there's we could drive a whole bunch of species to extinction. And there's an ethical thing. Here on top, how much climate change is a person causing? The reds up here are a lot of CO2 per person per year. The blue is not much. Down here is a vulnerability. If you have air conditioners, if you can have bulldozers and build walls against the rising sea, maybe you don't hurt too much from climate change. If it's really hot and you can't do much, you hurt. So red is really vulnerable to climate change. and red is causing climate change. This is not a golden rule plot. And a lot of faith leaders, including Jimmy Carter, including Pope Francis, have spoken eloquently on this. It's hard to get really happy about this plot. So that's one slide for each of the bullets here. Bigger economy, more ethics. How do we do it? There is a vast range of solution space. I'm going to highlight a couple. I'm not going to do all of them, but I'll highlight a couple. 2,000 calories per person per day of food. Where's it come from? Everything in color on this plot is either croplands in orange up here or grazing lands in this awful green down here. We've changed all of that land surface to give us 2,000 calories per person per day. Suppose we decided to build a solar farm to replace every bit of oil, coal, gas, our hydroelectric, our nuclear, and some future growth using existing technologies, the kind of things that are on our roof over my head right here. How big of a solar farm would run all of humanity? And there it is. Now, do not kid anyone. That's 30 years of building. That's huge compared to our roof. But could we get enough energy from the sun to run humanity? Of course. I wrote this book and we turned it into a PBS miniseries, and we went down and we talked to some Texas ranchers. And they had put 5% of the ranch into wind, little roads and things. 95% of the ranch is still ranch. They make way more money off the wind than they do off the cattle. They save the town, they save the high school, they save the ranch. They call it mailbox money. You go out to the mailbox and you get money out of it. If you put a wind farm on the windy parts of the plains and deserts of the world, that's about 5 times more energy than is used by all humans. Right now, the International Energy Agency has said that the best solar schemes give the cheapest electricity in human history. That's an amazing thing. Okay? There's a lot of people trying to save the farm. You just saw how they saved the ranch. You put wind over it. You can put sun over it too. And sometimes that loses the farmland, but there are ways you can put solar over farms that leave the farm working. This was an experiment at Oregon State where it's a dry meadow. They got an extra cutting of hay because it slowed down evaporation and it held snow underneath it. There was an experiment in Europe where they put really high solar cells that you could drive the tractor under. A drought hit. They got more food under the solar cells than they did in the control. You can put solar cells over the tomatoes, the peppers, they actually may grow better. You can put them over the irrigation canal out west and you can slow down the evaporation. There are ways that you can make more food by also making solar energy and wind energy. This is Lazard, claims to be the world's largest independent investment bank. And they said, what is the cost of adding a little electricity to the grid in the US if we got rid of all the subsidies for wind and sun? And let me just zoom in. This is unsubsidized for wind and sun. Cheap is over here on the left. Expensive is going this way. These are the big renewables. There's gas. This is coal. This is nuclear. Right now, it's really hard to keep running the nuclear and the coal that you already built and paid for rather than building and running new renewables. They're cheap. But this got rid of the subsidies for wind and sun. It did not get rid of the subsidies for fossil fuels. This is an estimate from people working with the International Monetary Fund that we're spending an immense amount of money on fossil fuels. A lot of this is the healthcare costs of breathing the particles from it. Some of this is climate change, some of this is direct tax breaks and other things. But they said this is a huge expenditure, 600 million in subsidies for fossil fuels in the US per year. So don't kid yourself. If we succeed in this, if we build a sustainable energy future, it will take the entire career of you students. There's a huge learning curve. There's a building an infrastructure to do this and replace one that has served us very, very well. It's going to be hard. We don't have every answer, but we now know that we can. And we're the first generation in history that knows that we can. And furthermore, we do have the scholarship that we can help the economy, we can help our health, we can help security, we can help employment, we can help the environment, we can help ethics if we do this well. And so I will leave you with a picture I took a few years ago. This is an iceberg in Greenland. Can we have a world that still has icebergs and rainbows? Absolutely, we can. Thank you for what you do. Thank you for giving me a brief peek into a wonderful climates program that you're doing in the College of Arts and Sciences. And I will shut up and take some questions now. So thank you.
Thank you so much, Richard. We appreciate greatly that talk and all the variety of things that you touched upon. Just a brief reminder, we've got plenty of space in the Q&A where you can type in questions and we can curate and pass those on to Richard. I'm going to start with one from Cian Rodwell, who asks, how do you recommend that we counter people who deny the need for alternative energy sources on the intellectual level that they need to conceptualize it?
Yeah. So fantastic question, Sienna. And I wish we could have a discussion because I would start by asking you what you think. My general argument these days is that most people actually realize that there's a need. The vast majority of people in the US and across the world are looking at renewable energy now as a way forward. There's something like 7 or 8% of the population who deny the science behind the climate change issues, but it's only that, it's below 10% now. And so if you meet somebody who truly, I'm not going to believe climate change is an evil lie and you're just doing it to take away my pickup truck, I would just stay off the climate science and I'd go right to the solution space. And we had a fascinating chat this afternoon with Professor Barbeau's class, and I was making a particular point about Ford F-150 electric. And I know there are other vehicles. It doesn't have to be the Ford. I'm not fronting for Ford, but you're starting to see people say, I could get that. I could plug a solar cell into that. I could plug my house into that. I could flip the bird at the electric company and do my own thing. And if the hurricane comes and my house survives, but the electric grid goes down, I'm okay. And so the people who are going to reject the climate science are interested in some of the solution space. And the solution space is so vast and it's so wonderful that I think you go to solutions and just don't worry about the science for that 8% or so.
That's excellent, Richard. Thank you much. I've got another question, this one from Andrew Hansen. What are your thoughts on nuclear energy as the advancement of next generation nuclear reactors continues?
Yes, so thank you, Andrew. I've been at this a long time. If you have a room full of people who understand the science, they're looking for solutions, they want to move forward, nuclear is the single question that is most likely to completely derail the discussion, and that's what you're going to talk about for the rest of the evening. That by itself says that nuclear is not yet ready to be the full solution because we can't get on board. There's so many issues in there. Right now, it's not economic. It's not shovel ready, as you saw from those prices. The people are shutting down nuclear reactors rather than operating them, not even building new, but just operating them because they're having troubles competing in price. There's a possibility that new nuclear will be great. Okay, people are working on it. But I can tell you that when I was a student, we were told that nuclear was going to be cheap and almost free and everything would be it, and nuclear was the answer. And since then, the price has gone up and the price of renewables has gone down. So I'm really happy by the research. I'm really happy people are looking into this, but it's not, new nuclear is not shovel ready at the point of we're going to build lots of it and you're going to have it plugged in your backyard and be happy with it. There are issues of fuel. There are issues of proliferation. Somebody could steal some and make a dirty bomb. There's a significant overlap between people who want to build nuclear for us and people who want to bomb nuclear for them. And who is us and who is them evolves over time. And there's a fascinating study that came out of Ken Caldeira's group that said that it's hard to stabilize an electric grid economically if it has a lot of renewables and a lot of nuclear. And so they tend to try to force each other out. And we've seen a little of that play out in public here recently. So like I say, I think I'm very happy about the research. If there's a breakthrough here, we're going to cheer, we're going to be happy about that. But if you wanted to move forward now, I don't think you can do it rapidly with nuclear, and you can do it with renewables.
Thank you.
So sorry, a long answer, and there's more to it than that.
Well, but to that end, Sophie Grimsley has a follow-up question to that. And so do you think other renewable energy sources like geothermal or hydroelectric are as scalable as wind and solar? Should we try to focus on specific renewables, in your opinion, or is it mostly based on location?
Yeah, so 1/100th of 1% of the sun that reaches the top of the atmosphere will run humanity. There is such an oversupply of sun that that one's straightforward. About 1% of the sun becomes wind. So if we could get 1% of the energy out of the wind, we would run humanity. About 1% of the wind becomes ocean waves and currents, which means that if we got all the waves and currents, that's just barely enough. So we're not going to run humanity on waves and currents. But if you have to build a breakwater to protect your city, you could build a wall and let the waves bang against it, or you could put a wave generator in front of it and take the energy out of the waves and use it. So this is where the sort of let's customize it for where we are becomes really important. And people on the coast who are building walls anyway probably want to find a way to use the energy that's coming against them. Geothermal by itself, steady heat flow out of the earth is really small. 0.07 watts per square meter. And, you know, nobody compared to 240 that's absorbed by the Earth system from the sun. You'll never hear the weather person talking about the geothermal gusts. But there's such a vast amount of heat in rocks that if we cooled off a lot of rocks a little bit, we could run humanity for hundreds of thousands of years. So there's a possibility of making geothermal really, really work, but there's real learning cost barrier yet. We've gotten most of the hydroelectric that we can get. The idea of pumped hydro, where you let it run downhill and then when you have extra renewables, you pump it back uphill, that's a different story. But there isn't a whole lot of hydro that you can get. And my personal opinion, we're eventually going to release water to on the schedule that's needed for growing food for people, not on the schedule that's needed to make power for people, because a hungry world is going to need that water for something else. So probably using the water to feed people and then using the sun and the wind to power them is your way forward.
I've got a comment from an anonymous participant. The primary issue with wind and solar is that it is intermittent. By itself, it will never replace the constant fuel sources like coal, nuclear, gas. That means we must have batteries to store the energy. China, the most polluting country, controls the world supply of both solar panels and lithium. From a national security standpoint, that is neither desirable or acceptable. Any comments on that?
Yeah, so absolutely unequivocally, wind dies, sun sets. There's lots and lots of opportunities on how to deal with this, right? So the first one is you interconnect over bigger areas because there's less problem with that. You build offshore wind because offshore wind is more reliable. And then you start thinking about storage fairly broadly. pumped hydro. There's a lot of things you could think of in addition to lithium ions. You have some geologists who are actually looking for lithium elsewhere, and they're finding it. It's not all in China anymore, so don't worry about that. It's an issue. It's a national security issue who controls minerals, but there is lithium elsewhere, and so that's true. But there's also this vast learning curve on finding more common element batteries, and they're gaining pretty fast. There's a lot of learning there. There's, one way that comes out, the studies that are done, one way that comes out is that it's so cheap to do wind and sun now that you just vastly overbuild. And once you've vastly overbuilt, you tell people almost free energy. And then you see what they do. And some of them, people are starting to work on this idea. Can you split water, make hydrogen, and use hydrogen as your battery, your liquid fuel, your gas fuel? You can do that. Or you let people desalinate and pump and water the desert. And if you wanted to make some biodiesel to run your planes on, well, you could do that. You tell architects you're going to have really cheap energy. If you can put a heat sink in your building, when the energy is cheap, you buy it. When the energy is expensive, you quit and you use your own. Penn State has a fleet of vehicles. So do you, the University of South Carolina. Those vehicles are capable of driving 300, 400, 500 miles. Most of them drive across campus. Okay. At the point where they have batteries and they're capable of driving 300 miles, but they drive across campus, what could you do? You plug your car in when it's stopped, and you push a button that says, I'm not driving across the state, I'm only driving across campus for the next day. My battery is now free to be a contract piece for the University of South Carolina. And when energy's cheap, we'll buy it. And when energy's expensive, we'll sell it back. And we're going to pay for our power by the batteries of our fleet being the stabilizer for the grid. And so the amount of possibility, the new things that can be done, we do not have a stable all wind and sun thing at this point, but we can. And there's a lot of plans on the books that use existing or easy to see technologies to move in that direction. And the truth is, baseload might be bad for that. There have been times that electric utilities that rely heavily on nuclear and coal have gotten themselves in economic trouble. If you're in Chicago and you have a nuke and you have a coal, you have to put the power out. They can't follow the load. You can't turn them down for an hour the way they're designed now. And when the wind is blowing in Iowa and there's a lot of electricity on the grid, there were times that the price of electricity went negative. They had to pay people to turn off their wind so they could put electricity on the grid. And because the coal and the nuclear are more expensive, that in turn base load, batteries would have done more for nuclear and coal than they would for renewables in that system. So one needs to think broadly at this point and to start thinking about the cheapest electricity in human history. What can we do with really, really, really cheap electricity, really cheap power that we can get lots of?
As a state that's 50% nuclear, that's really important to be considering too.
It's fascinating. And I don't want to dump on nuclear. I have friends in the nuclear engineering department. I'm glad I do. My brother worked for the Nuclear Regulatory Commission. I'm glad he did. But nuclear is, right, and among other things, because the government carries the long-term and catastrophic insurance for nuclear, essentially everywhere and all the time. If you like nuclear, you better like the fact that my brother worked for the Nuclear Regulatory Commission. And I'm afraid there's a lot of overlap between people who like nuclear and who didn't like my brother, and that won't work.
Yes. So As I think I mentioned to you that my class has started reading Ministry for the Future recently. And so we have a question from the audience that is not in my class about said book. And so it's from Todd Shaw. And it's, thank you so much for this presentation. I have been reading Kim Stanley Robinson's Ministry for the Future. As a sci-fi writer, he provides a dystopian vision for our climate future. He feels there'll be a lot of chaos that will eventually compel us to move to a sustainable future, or else. What do you think?
I think there's a lot of wisdom there. I always like sci-fi, and so I think that we can cause real trouble. We do know, I mean, we have evidence from far in the past, big belch of carbon dioxide that made it hot, and the large warm-blooded animals in Wyoming became dwarfed. And sort of were replaced by others migrating in from Asia. And so, you know, a lot of CO2, and what happened is migrants from Asia, dwarf migrants from Asia took over Wyoming. That's a little oversimplified. This is a Pliocene Eocene thermal maximum, but we know that we can make things really hard. There's evidence of deep time of the end Permian extinction. Volcanoes poured out a lot of CO2 and killed most of the things on the planet. There weren't large creatures living near the equator as far as we can tell. And so if we make it to the point that it's fatal for an unprotected human to live near the equator, they're not gonna, it's very unlikely that billions of people are going to sit near the equator waiting to die. And they're going to try to get air conditioners, and they're going to try, but if they can't get them, there's going to be migrants. And so these sorts of things are on the table. It's fairly clear that we can miss that. And it's fairly clear we could miss it by a lot. But if you do the worst case scenarios, they're not at all pretty. And so we're at this time that if we were to double down on making it bad, we can make it really bad. And if we double down on making it good, we can make it really good. And we can muddle through somewhere in between. I'm sorry, that's not a very good answer. And I'd also love if we could open it up and let you give your answer. And Dr. Z, I don't know if you want to give a little bit there.
I know that it came up in my class today that the students felt that perhaps we needed to break it all down before we could build it back up again. And so the chaos was what they were starting to wonder if that needed to be the solution, which was frightening to consider as well.
Oh, the chaos makes perfect sense. There's an old Joe Diffie song. Sorry.
I just wanted to be, are you okay to answer some more questions for it? Okay, cool. So I'm kind of combining two different questions right here in terms of Aaron Mayer Goodbrow, who's a prof in the School of the Earth, Ocean, and Environment, and then also Bob Petroulis, who's involved a lot in city work in terms of climate change action. And so this is kind of meshing the two together. And this is, what is the most important step that we as students and citizens can take to push our government into taking these solutions seriously, cutting fossil fuel subsidies, funding renewable infrastructure, R&D, etc. And how hopeful are you about the outcome of COP26?
Yeah. Oh boy. So I mean, vote, talk about it. You know, this people need to know where you are and what you're thinking, and so that would be it. For you students, be students. Learn. We need, Dr. Barbeau and I were chatting about this afternoon. We need a few of you to be professionals in this. And you're going to design the electric switching. You're going to do the ad copy. You're going to be the artists. You're going to be the scientists. We need a few of you to be professionals in this area. Most of you are not. You're going to go out and do whatever. You're going to be teachers and doctors and lawyers and business executives, and you're going to do good things. And when you see the win-win, when the moment comes up that you can do your job well and help your company or help your patients or help your students by bending it in the direction, you're going to do it. And if we all are doing that, there's a few of you who are moving things from the bleeding edge to the leading edge, and the rest of you are waiting to grab what hits the leading edge and to use it to help your people. We're good. COP26, we're not going to solve all the learning curve on building a sustainable energy system is hugely steep. I think it's grossly oversimplified to expect that the learning curve on building international agreement to use our knowledge will be easier. In fact, I tend to think that the technical part is easy compared to the human, the social, political, the legal part. And so Dean Samuels is actually an expert on these cross-border issues. And I don't know, he probably will refrain from chiming in, but if he wants to chime in, Dean Samuels, do you want to say something there?
No, only that I'll let you keep talking. I am learning more than I could ever impart in this conversation, but I do enjoy the conversation. I mean, I will say one thing, which is, as Richard's sharing, I do a lot of work on international boundary disputes. And in my view, I shared in our earlier conversation before this started that I do a lot of work on maritime piracy. What I didn't share is why I do that work. I do that work because, in my view, maritime piracy is responsible for the creation of the international law system. In the period when piracy existed and when international law didn't exist, there had to be some solution for what happened in spaces that no sovereign territory controlled. And that's what developed international law. And in my view, going forward, environmental law is the one area that will sustain the development of international law, because it's the one area that doesn't stop at borders. And so when you think about why because we don't need international law, states can negotiate between themselves and other actors. So that would be my one contribution on that, which is I think international law has a role to play in this, and I think it often ends up being more of an impediment than the positive force it should be.
Outstanding. And so this business of how do you as a student help, I hope you just heard from a leading law expert, there's a lot of ways to do so. And so do not, like I say, we want a few of you as scientists, we want a few of you as engineers, but a few of you jolly well better be listening to what Dean Samuels just said.
Richard, we got a combination question from a pair of folks in the audience, Maggie Gordon and Victoria Franklin. Maggie asks, are there any new developments or technology in renewable energy that you're particularly excited about? Then perhaps related, Victoria asks, what do you think are the biggest factors preventing world leaders from implementing renewable energy?
Yeah, so thank you, Maggie and Victoria. Maggie, I'm especially excited by this possibility of our universities doing the land grant job and helping farmers save the farm by figuring out how to overcrop. I don't like the look of a lot of solar cells getting rid of farmland. And so the question, how do we, as land grant institution, learn to let the farmers grow food and do their job and keep the farm? Because if you're near a city now in a lot of places and you're trying to farm, you can't make enough money to keep the farm. And what does that do to us as a society? What does it do to our ties to history? And if we can learn how to overcrop these things and power the people while doing better for the farmers, I think that's a really interesting thing. So that's, and I'm sorry, Victoria's then was.
If there's any particular reasons why you, or the largest factors.
Yes, why are we not? Oh, I'm sorry, Victoria. Thank you. A lot of it is inertia. We know how to, if you buy an electric car, where are you going to charge it? And you buy an electric car and your garage doesn't have a plug. And so now you have to pay an electrician to come in and put 220 in the garage. And if we had a stable system that we had built for this, think for a moment, suppose we had a whole bunch of chargers, suppose we had a whole bunch of electric, and somebody said, we're going to bring in gas and oil. We're going to drill holes in a whole bunch of people's backyards. We're going to cut pipelines through a whole bunch of neighborhoods. We're going to have some oil blowouts, and we're going to kill a whole bunch of things on the coast when the oil tankers wreck. We're all going to burn something, and it might put carbon monoxide in your house, and it's going to kill you. This stuff is really explosive. It's not just fire like a lithium battery. You drop a match in a gas tank and it blows up. We're going to dig a whole bunch of holes under a whole bunch of street corners and put tanks full of gasoline that some are going to leak into the groundwater so you can't drink it. We're going to build all of this stuff. There isn't a chance in heck that we would allow this to happen. But all of those barriers have been surmounted over a very long time by very clever people solving problems. We can solve those problems for a sustainable system, but think about what went into what we have, and recognize that we have to surmount those. And on the far side is the system that is better than what we have, fairly clearly now. It looks cheaper, it looks more stable, it looks more sustainable, it looks with fewer problems, healthier people. But oh my, there's a big issue of transition. And so that's it. And like I said, I keep saying moving from the bleeding edge to the leading edge. In a lot of ways, we're still on the bleeding edge. We want to get to the leading edge.
Richard, thank you so much for all of these answers. We have a question that I think would make a great last question for you. And that's from Tracy Goldson. And it's, what should be the primary focus to reducing carbon dioxide in a way that decreases a fast-paced pathway to climate change? Ideally, if you were president and needed no other agreeable parties, what would be the first change you would make for the USA to begin combating climate change in one word?
I'm going to sound like I'm an echo chamber. I'd say renewables in one word. So I think that, but then, you know, I'm a professor. The kids used to joke. They'd say he has a professor button, and then they'd say, "Uh-oh, you pushed this professor button. He's about to profess," right? So one of them's a teacher, and the other one's a professor, but he's about to profess. And so I think that one word really could be innovation. And it could be, I don't know if you'll let me hyphenate, problem solving. We can solve problems, and solving problems is going to take all of you. And I guarantee you it takes the artists as well as the engineers. I guarantee you it takes the writers and the historians, and it sure as heck takes the lawyers. And so if you let me hyphenate two, we'll say problem solving. If it's only one, it'll be innovation. But what you're doing there, what you're doing, and Dean Samuels and Dean Whitted, thank you. What you're doing there of doing this across the full breadth of your fields is what we're going to have.
Excellent. Thank you so much. And we really appreciate you taking this time to come visit us virtually in our classrooms and here tonight. Oh, and I see that Dean Samuels is also coming on to say goodbye.
I guess whenever I turn on my camera, that means I get to talk or have to talk. But I just want to join Lori. First, I want to thank Lori and Dave for their work in putting this together and for moderating the conversation. I want to thank Kiana for spearheading the theme semester. She's really now leading the process. And I want to again thank Cynthia Davis for being the mastermind behind this. And Richard, I want to thank you. I think on behalf of the over 125 participants in this conversation who, as you point out, unfortunately, you don't get to see and experience in sort of the same ways. This has been such an engaged conversation, and thank you for sharing your thoughts, for sharing your optimism, and for sharing your vision and your experience from science. And I think it means a lot to all of us. So thank you for being the keynote speaker for this year's climate semester. And we look forward to engaging with you again sometime soon.
I look forward to it as well. Thank you so much. And to all of you online, take care. I wish we could have seen you in person, but thank you for coming.
Be well, Richard. Thanks.
Thanks.